Okay, so right now we're going to be talking about solving inequalities. Now what makes this an inequality is a symbol just like that. The greater than, the less than, greater than or equal to, or less than or equal to. These are statements of inequality, saying that things aren't equal, but actually one is bigger than the other. Now, even though they do have that difference that we're no longer talking about things being equal, we're going to treat it a lot like we would our equals sign. Now, I'm going to start just by drawing my line down the middle that goes straight through that inequality symbol. Just so that whenever I say I'm going to do something to both sides, we're really clear on what I'm talking about. So, to start with, I've got a positive 9 over on this side. I'm going to subtract a 9 so that I can get 0. 0 plus the 4t leaves me with just 4t. 21 minus 9 is going to give me a 12. All of this should start looking familiar, just like we were solving equations. All right, and I'm going to bring down that same symbol. It's still there. Okay, now I've got 4 times t, so let's do the opposite of that. Divide by a 4 on both sides again. Now 4 divided by a 4 is just a 1. 1 times the t gives me t is greater than 3. And we finished. We've solved it. T can be any number greater than 3. One of the ways that we sometimes graph these things is on a number line. So I'm going to have my 3 right here, 2, 4, 5. Now, this all kind of centers around the 3. However, I can't equal the 3. So that dot I drew above there is empty, just because we can't equal 3. But anything above 3, this going on forever, 4, 5, 6, 7, 8, 9, 10, even 3.5, anything that is above that 3 mark is something that t can equal. So that's how I solved it. This is how graphically I'm kind of showing all possible answers in existence. And there are an infinite number of answers, infinite number of numbers that are bigger than 3. All right, now here we're encountering a word problem associated with this. So in our community garden, we want to fence in a vegetable garden, keep all those rabbits out, that is adjacent to our friend's garden. Who isn't gardening right next to their BFF? I mean, you know, it's what we all do when we have some spare time, go out to the gardens. So you have at most 42 feet of fence. So what are going to be the possible lengths of your garden? So let's look at what this problem also gives us. So here in red, we got our friend's garden. We can see that since he's already made his garden, we already know kind of the width that we're going to make. So we're going to have a 12-foot wide garden. What we don't know is how long we're going to make our garden. So we just don't know that one value. So we already know the width, but we haven't quite figured out what the length is going to be for us. Okay, but this is a perimeter problem. All right, so because this is a perimeter problem, we can go ahead and use this equation. Now, with the perimeter, we already know that's 42, but there's something different in this problem in that I don't have to have a garden that uses all 42 feet of fence. Maybe I'm not as big of a gardener as my friend is. All right, maybe a few herbs and I'm okay. All right, maybe a carrot thrown in there for good measure. And now I'm healthy. Good, I've done my gardening. So it says at most 42 feet is the most we can use. So rather than an equals, I'm going to put 42 is greater than or equal to our 2 times the length plus 2 times the W. So whatever length and width I happen to use for my garden, it can be less than that. I just can't go greater than 42 because, well, I don't have enough fencing to do that. All right, next I'm going to substitute in some of the values I know. I already know that the width is going to be a 12. So we have 2 times 12. So this 42 is greater than or equal to 2 times the length plus a 24. All right, and now I just need to continue solving for that L. I'm going to draw my line straight down so I can start doing things on both sides. I'm going to subtract a 24 from here, subtract a 24 from here. So that's fencing all of my width. After I've fenced in the width, that would leave me with just 18 feet of fencing left. Now I got to fence in my 2 lengths. All right, so I'll divide that into 2. All right, and so my length has to be less than or equal to a 9. So if I only want to do 8 feet, that's good. If I want to do 7 feet, that's also good. All right, if I want to go the full 9 feet so that I can maximize the amount of gardening I'm going to get done, I can do that as well. All right, but this shows how we're using these inequalities to find all the possible values, not just a single value, but all the possible values that could work for this particular problem. And now I can go back as the professional gardener and figure out what's going to work best for what I'm growing. Okay, so now we've just got slightly more complicated problem. Not too much though. So first thing I'm going to do, I see these parentheses, and I'm just going to go ahead and distribute that through. So 3t plus a 3 minus a 4t is going to be greater than or equal to -5. All right, next 3t minus 4t, so that's -1t plus 3. Now at this point, if I wanted to just call that -t, I don't have to write -1t. And I can get rid of that right now. I'm going to leave it like this for right now, and I'll show you in a moment. All right, now first let's go ahead and try and get t alone. So let's minus that 3 on both sides, and I'm going to have my -1t is greater than or equal to -8. Okay, but I don't care about what -t is greater than. I want to know what positive t is greater than or less than. So what we're going to do, and here's kind of why I kept the 1. We didn't have to do it this way, but I think it makes it clear. Since I'm multiplying by a -1, I'll divide by a -1. All right, now if I divide by a -1, just get a positive t here, positive 8 here. Now I'm about to do something that's a little weird. And this is where inequalities suddenly become different from equations. I flipped that sign. Now most of the time when I show this, a lot of students are just like, wait, why did you do that? And that takes a little bit of time to learn. So I'm going to try and show you the simplest way I can. Let's start with something simple. +1 is greater than a -1. All right, now let's try doing just different operations to both sides of this. Let's add a 2 to both sides. Now if I added 2 to both sides, I'd now have 3 is greater than 1. All right, well that's still true. What if I subtracted? Let's subtract 3 from both sides. Or no, let's just subtract a 1. 4. From both sides. Okay, so when I do that, then we're going to get -1 is greater than -3. And that may seem odd, but remember, for which is greater, we're focusing in on which is higher in the number line. And that -1 is definitely higher on the number line. All right, so we notice if we add numbers or subtract numbers from both sides, it still stays equal. So what if we try multiplying? So So if I multiply by 2, well, I get 2 is greater than negative 2. Well, that's still true. If I multiply this, though, by, let's say, negative 2 this time. So rather than positive 2, I'm going to multiply by a negative. So now that becomes negative 4 here and positive 4 here. So now we notice that sign can't stay the same. I need to switch it around. That sign now needs to say that we're using less than. So why did that happen? It happened because we multiplied by a negative. Now, multiplying by a negative means that your positives are now going to become negatives. So in other words, your bigger numbers are now going to become numbers that are lower down. And your negative numbers are going to become positives. So my low numbers are suddenly going to become high numbers. So because of that reversal, all of the lows becoming highs and the highs becoming lows, we need to reflect that in our inequality symbol. And you'll notice that's exactly when I did it too. We had divided by a negative 1. That's going to cause that reversal, okay? Where negatives become positives and positives become negatives. And so I flipped that inequality. So keep that in mind when you work with inequalities, that if you multiply or divide by a negative, you've got to flip that inequality, okay? But only in multiplication and division by a negative. We demonstrated how if we add a number, doesn't change anything. If we subtract a number, not still good. We keep that inequality the same. If I multiply by a positive number, it still stayed the same. It is only when we found that situation where we were multiplying by a negative or dividing by a negative that we suddenly needed to switch this around. So that's the only time that you're going to suddenly flip that inequality. All right, now we got the variable on both sides. So I'm going to go ahead and start solving this one. So first, I want to get the variable on only one side. I don't like that it's on both sides. So let's get rid of 3n over here. So my 3n minus 3n, that's a 0. So I'm going to have 3n minus 1. 0 plus 8 is just 8. Same symbol. All right, now plus the 1, plus the 1. Negative 1 and 1 is a 0, so 3n minus 0 is just 3n is greater than 9. Final step, divide by 3, and n is greater than 3. Now, what if I chose to do this in a slightly different order? What if I chose to do just some different steps? So let's try a 6n minus 1 is greater than 3n plus 8. But rather than minusing the 3n, what if I decided I want to subtract a 6n? Now, for me personally, I really like to subtract the smaller number because I avoid negatives like what I'm about to get. But that doesn't mean that it's wrong. Okay, so I can get a negative 3n plus an 8 over here, minus the 8, minus the 8. So I'm going to have my negative 3n is less than negative 9. We're seeing some pretty similar numbers at this point. Divide by negative 3, divide by negative 3. So I'm going to have an n. Now remember, once again, here we're seeing that division by a negative number. So I'm actually going to flip my sign, and we'll get a 3. So between these two, we essentially got the same answer. So they're equivalent statements. N is greater than 3 or 3 is less than n. But also notice that had we not flipped the sign when we divided by that negative 3, we would not have gotten the same thing. All right, now that's the importance. You can do your work in whatever order you want, but if you're forgetting little things like that, you're going to arrive at different answers. All right, so that's where that's important. Now we're going to see a couple special cases of solving for inequalities. So let's start out with just that distribute. So 10 minus 8a is greater than or equal to 10 minus 8a. All right, now some of you might notice very quickly, well, both sides of that are exactly the same. Yes, they are. Now, just by noticing that, I can already say what the answer is. But I also want to take it a little bit further, because sometimes you're going to solve equations and it's not going to be that obvious that they're the same this early on in the game. So I'm going to do my step where I try to get the variable on one side. Now, as I do that, both of my a's eliminated. A negative a plus an 8a is 0. So I got that 0 on both sides. So I'm just left with 10 is greater than or equal to 10. All right. So this can happen sometimes. You're working through a problem, and as you try to get the variable on one side, it eliminates from both sides. In this situation, I want to be asking the question, true or false? All right, so is 10 greater than or equal to 10? Well, the answer is true. That's absolutely true, because we've got the or equals to in there. Now, because it's true, that means any number is a solution. All right, and so we can go back to that one statement we noticed where they are both the same. It doesn't matter what number I put in for a, that's always going to be the same. If we put in a 0 for a, both sides will be the same. If I put in a 1 for a, both sides are going to be a 2, but they'll still be the same. Any number you put in there, they'll still be equal. And because we've got that or equal to option here, this is always going to be true, and every number is a solution. So when you're solving, your variable eliminates, and you get a true statement, any number is a solution. So wild guess as to what kind of situation we might find here. All right, now on the right-hand side of this, I can see that I've got a 7m minus an m, so we'll just change that to 6m. All right, and now, once again, I'm going to try and get my variable on one side, but we do have 6m's on both sides, meaning that when I do this, I'm going to be left without my variable anymore. I'm just going to have a negative 5 is greater than a 7. Now, that is flat out false. This is not true. Negative 5 is not less than 7. Now, if this is false, that must mean that this is false, which also means that this is false, just everything we've been working on. There's no way it's true. It is just a false inequality, and it can never work. So the answer is that there's no solution. There's no value of m that I'm going to put into this that is going to make that true. And so this has been Inequalities. I hope this helps you, and keep on going. Keep trying and don't give up.